Umar, I'm so excited to have you here. This is the first time we've had somebody who's actually like in the team at Writer, one of my coworkers chatting with me on Humans of AI. And ultimately, yes, we'll talk a little bit about Writer, but we want to hear about the people behind this technology. And you are deep into this technology. So I would love you to introduce yourself, do your typical elevator pitch type of intro, and then we'll dive into our conversation.
First of all, thank you, Alora, for having me here, and I'm also very excited to be here and to be, sharing my experiences and my perspective and my life. So, who am I? My name is Umar Jamil. I come from Italy. I am currently living in Germany since April. Before that, I was in China, so I've been traveling a little bit around the world. I'm a software engineer by trade, recently focused on machine learning, and I'm working at Writer as a machine learning engineer and researcher. My focus is language models, so large language models. I also run a popular YouTube channel focused on machine learning. I reached 40,000 subscribers recently. I would say my focus is mostly on the research side of machine learning. So, like the deep learning models and how we scale them, how we train them, how we use them, etc. So, the techniques inside.
I want you to tell me about the first time you remember encountering AI or interacting with AI, and please define that however
Mhm.
you interpret that question.
All right. I think that happened much earlier than you would expect with video games. So when I was a kid, I used to play a lot of video games, and video games they also have some kind of AI intelligence in them, meaning that you have these characters that need to kind of make decisions on how they need to act, and there was some form of like a machine learning also back then to train these characters to be more natural, to be more like to make decisions not always deterministically, like not in a predictable way always. So that was one of my earliest encounter of AI actually.
What was your favorite game?
Well, I used to love strategy games. So for example, one of my favorites was Rise of Nations. That's like a real time strategy game from Microsoft. It's like you build your own nation and you need to protect it and battle with other tribes, etc. It's very nice, and there was some form of AI also there because you can play against the computer and the computer makes decisions that are not only based on rules but based on like learning algorithms.
Interesting.
Yeah.
We might circle back to that a little bit as we talk a little bit more about these learning algorithms. But one of the other questions I often ask our guests is how you interact on a personal or professional basis with AI. So talk to me about that relationship with AI too.
All right. Well, being a software engineer, I use a lot of coding tools, and recently I really interact with a lot with GitHub Collab, and I'm playing with a lot of IDEs, so the programming environments like text editors that have some AI embedded in them. Because when you code, actually there is a lot of repetitive work, and having an AI assistant help you makes you much faster and it makes your job much less boring. Like you focus more on the logic instead of on copying and pasting stuff. So yeah, that's my primary use for AI tools. Another thing is generating images. I have been playing with a lot of services online. Recently, I realized I lack a photo, like a photo shoot, a professional one. So I made a headshot online. In a very fast. It's very fast and convenient.
Yeah, thank you for the recommendation, by the way, because I did one too, and been getting compliments. Like people are like, "Oh, you look like a Ford model." I'm like, "Well, AI does good things sometimes."
Yeah.
And then, I mean, obviously, you're using these tools to build an AI system, correct? I mean, these coding
Yes.
tools are
Yes.
helping to go into what the code behind Writer too, without getting too proprietary here. Talk a little bit about your role at Writer and what kinds of projects you've been rolling your sleeves in.
So at Writer, I'm focused on research, and my team works on large language models. So we are researching, for example, how we can make them more efficient to run, how we can make them more effective at processing longer prompts, for example, or we train them, we fine tune them, trying to improve their score on some metrics that we care about. So overall, our primary goal is to find new ways to improve language models. That's the final goal, yeah, because this is the primary tool that everyone is using, to run most of the AI systems right now. And one thing that I'm really excited about is that there is a lot of different modalities that are now converging into one. So before, for example, you had image models, text models, audio models. Now you have these models that are multimodal, and they are trying to combine all these multimodalities into one bigger model, which can kind of leverage the audio input, the image input, and can output audio, can output images, can output text. So it's kind of creating a super system that can process all of this stuff, just like a sensory system for a human.
That's amazing. I can't wait to talk to you a little bit more about that. But first, I would like you to talk us through the journey of how you discovered machine learning. You talked about this process in video games, and that, what hooked you into that? Where did you go with that?
So I would say it was a love story between me and my wife that turned into a love story between me and machine learning. So I was living in China. I was working for an Italian company that had a headquarters also in China. And I was traveling quite a bit. So I met my wife through one of these travels. And my wife is a machine learning engineer. She was focused on speech generation, so like a text to speech models that can generate audio, basically. At the beginning, I was not so familiar with machine learning, despite having some kind of background. But as soon as I met her, I started digging deep into what she was doing on a daily basis and how it worked and what the things she was doing. I saw her coding, and I saw the kind of things she was doing. So I was kind of fascinated, right? That led me into getting a master's degree in artificial intelligence, which gave me the foundation to study these models in a more deeper ways, like from a mathematical point of view, which then led me to explore more the research side of machine learning. And that's how I kind of dig deep into machine learning. So it's basically, if I didn't meet my wife, then I think there wouldn't be a YouTube channel that I would be running about machine learning. So
So to sum up, you became a machine learning expert to impress a girl. Yeah?
yeah, kind of, yes.
Classic,
yeah,
classic
yeah,
love
yeah.
story. That's amazing. There's some other interviews you've done where you've talked about that this transition into machine learning was very challenging. Talk to me about that.
All right, so it's a long story. So let's start from the beginning. So I met my wife, and I wanted to, transition into machine learning, like doing it for a living, right? But I was working in software engineering, mostly in industrial cases. So the first thing I did was to, study and get a master's degree, because that builds the foundation for understanding more complex models. But eventually you need to take the leap of faith, which is, okay, I want to do this full time. So I was working full time. I was working as a manager, so I didn't have much time actually to dedicate to my personal research about machine learning. So first, before taking any leap of faith, I wanted to convince myself that this is really what I want. So I started spending more and more time every weekend, every night, studying machine learning models, studying, coding machine learning model from scratch, so to understand them better, etc. Eventually, I decided to quit my job and dedicate myself fully to machine learning. I said, okay, I want to do it. I know I will be able to do it, because in my life, I have faced many difficulties, and I learned that I can always overcome them with time. So if I really want it. So first, I needed to prove myself that this is really what I want. So after I proved to myself that this is really what I want, because you can prove that to yourself when you dedicate a lot of time to something, it means that you are really, and you are sparing all your available time for that, then you are kind of proving to yourself, this is really it's not something just, I saw it online, it's cool, so I want to play with it a little bit. So I started dedicating a lot of resources also to studying machine learning. And then I decided to quit my job and started studying every day machine learning, because if you want to enter a field, I believe that you need to, first of all, you need to learn the basics, but then you need to kind of build the foundations that can make you reach faster to the target that you are trying to reach. So basically, I started waking up at 4 a.m. in the morning to study. And I used to study until 9 at night. It was not hard for me because when you are passionate about something, when you're driven, it comes naturally. Like you wake up in the morning, there is this burning sensation like, okay, I need to keep the fire lit. So I used to do it like this. I did it for like nearly 7-8 months, I would say. That built the foundations, and it built a lot of knowledge that then I leveraged then to build bigger projects. So I started, for example, my YouTube channel because I was always talking to my wife about papers. So I read some papers and I started discussing with my wife about these papers. And my wife, one of these, I mean, after a while, I think she got tired, and she said, you're really good at explaining. I mean, I can see that you are, passionate. You are, you can simplify concepts, complex things. You can explain them in a much simpler way. So why don't you explain to a bigger audience, and then you can help others who are doing the same transition. And that's how I started. So I started by publishing videos. Initially, I published, a video about the transformer with such a bad audio quality that you would never listen to it. However, the video content was good. And people liked the video so much, they started commenting saying, man, I was going to give up to this video because of this bad audio quality, because I used my phone microphone to record it. But thank God I didn't give up. I just, kept watching for 5 minutes, and the content was so good. Thank God. And it was a 50 minutes video.
Exactly. I wanted to point that out. These are not like 3-minute TikToks. These are lengthy videos. These are entire courses in one video on these
Exactly.
deeply technical topics. For anyone out there who isn't familiar with what machine, we hear AI all the time, but machine learning is its own concept. As somebody who does a YouTube channel about machine learning, what's a quick high-level definition of what machine learning is?
All right. So when we talk about AI, we are talking about something very big that includes a lot of techniques to develop AI. So first of all, what do we mean by artificial intelligence? We mean by artificial intelligence something that can resemble human intelligence, but built by humans. So it has some kind of reasoning skills that humans have. Of course, there are a lot of definitions of what is AI. Okay, let's make another step back. When you study function in high school, you are given X and you get Y as output, right? So they teach you, okay, a function is something that you put X and you get some output, like X to the power of 2, so you get some output. What we do in machine learning is we have a lot of data. We have a lot of pairs of X and Ys, but we don't know what is the relationship between them. So in high school, they give you the relationship. You give X and you get Y. Or you give the input and you get the output because you know what is the relationship. In machine learning, we have the input, we have the output, but we don't know what is the relationship. So for example, in language models, what we do is basically we teach a language model to predict what is the next word that is most likely after a particular prompt, which is the input. We know because imagine you have an article, you take the first two words, then the third word is what we would expect the language model to generate when it sees the first two words. So we have the relationship between input and output, what we want the model to generate and what we give the model as input. But we don't know what is the relationship between two. So machine learning, basically, it's a list of techniques that allow you to learn this relationship by leveraging data. This is the most simplistic way I have. Imagine another way is, for example, you want to train a self-driving car, and the self-driving car has to learn how to recognize the stop sign. Now, we do have a lot of pictures of stop signs. We have a lot of pictures, and we know which one is a stop sign because humans have spent a lot of time labeling them. Like, this is a stop sign, this is a stop sign, this is not a stop sign, this is not a stop sign, this is a stop sign, right? So we do have the relationship between what is the input of the camera and what is the prediction from the machine learning model, which is, okay, this is a stop sign. And then we need to find a way, like a relationship between this input and output automatically. So we want the machine to learn. This is why it's called machine learning, this relationship. So whenever it sees a particular image that resembles a stop sign, next time it will say, okay, this is a stop sign.
And, when we talk about generative AI, oftentimes we are talking about these are prediction machines. These
Yeah.
are ultimately recognizing a pattern and predicting the next step in the pattern. And machine learning is finding those relationships between this step and the next step. Yes?
Yes, this in the case of language model is exactly like this. In the case of, for example, image classification, which means that you are given a picture of a cat or a dog or a tree, and the machine learning model will tell, okay, this is a cat or this is a dog. It's not predicting what is, for example, the next output, but it's just classifying.
Classifying. Mm-hmm.
Yeah. Then you have like generative models, for example, image generation models. They recently they work with what is known as a diffusion system. I can explain it very briefly if you have time. Otherwise, we can skip that.
We don't have to get into the deep technical concepts here, but yeah, I mean, we simplistically said this is, how we find those relationships. Now that we've kind of laid this out, okay, so here's like this whole new way of thinking about training computers, teaching machines. What lights you up about it, right? What got you up at 4 a.m. and working until 9 p.m.? There's got to be something other than, ooh, I want to find the relationship between X and Y.
I'm very fascinated by difficult problems. So the more difficult the problem is, the more fascinated I am. The more challenging something is, the more fascinated I am, because I believe it's a human nature to love complexity. Sometimes we like simplicity, but eventually people like noise in their life. Imagine a very linear life. Some people could accept that, but a lot of people would, just go get a little bit off the path. So I like questions to which the answer is not easy. So right now, for example, we are trying to find ways to model, for example, text distribution. So how do we generate text? How do we do it in an efficient way? How do we do it in a fast way? How do we do it in a more human way? So how can we improve, for example, the creativity of a language model, which is, instead of just rewriting what you have learned, maybe, be a little less predictable. And it's something that is always changing. Like what we have today, I think it's gonna change in 3 days. So in 3 days we are gonna have something totally new. Yeah. And this is also one of the reasons I got into computer science in the first place. So I started coding very young, mostly because I was using the computers, but I wanted to learn, how do I make these programs that I'm using every day? How do the video games that I'm playing with, how does it work? How was it coded? How do they make the logic? How do they, the characters, how do they decide what to do next?
Do you remember one of the first coding projects you ever finished? And you were like, okay, yeah.
My first coding project was a calculator. Yeah, I think that the most simplistic, yes. I was 10 years old, I think, 9 or 10 years old. And I was teaching myself alone how to code by using a book that my brother bought from high school. And I didn't actually understand most of the code that I was just copying what was in the book and just recreating step by step what was. I made calculators for a few months without actually understand, because I was so fascinated with the ability of to make things, to make something that was not there yesterday, so to create things.
And so fast forward to today, talk to me about the projects you're working on with, again, we got to keep things down low, but either for your channel that you've been talking about, you could also maybe the writing in the margins paper is something that can get you excited. So talk to me about that a little bit.
All right. So actually, there are a few projects that I'm quite proud about. One of them was coding Stable Diffusion. So Stable Diffusion is one of the image generation models that we have today. It's basically a text to image, meaning that you describe what kind of image you want, and the model will generate an image. It's based on diffusion models, and I believe one of the few people in the world who coded it from scratch, and I think I'm the first or second person in the world who actually made a video on how to code it from scratch. Because it's quite complex. There is a lot of mathematics behind it. To summarize how these systems work, basically they work like this. How they train this model to generate images, novel images. Basically, they take a lot of images, they scrape them from the web, so like image along with the description of the image. They add some noise to this image, like the kind of noise you have in the old television, right? When the signal is not right, white noise. They add a lot of white noise to this image, and then they teach the model to remove the noise. But they do it iteratively. So they start from the picture of a cat, they add some noise, and then they add noise, until it becomes completely white noise, and then they ask the model to reverse the noise. What happens is that if you start from pure noise, the model will probably arrive to one of the images that it has learned or something in between. So you start from a lot of picture of cats and a lot of picture of dogs. You'll teach the model how to denoise them. Then if you start from pure noise and you tell you want a cat dog, it will probably arrive to something in between. So that's more or less how they work.
I had no idea that's how this works.
Well, actually, okay, it's a little more complicated.
No, that's how it works. No, I'm
Yeah.
kidding. No, I mean, that's so cool. And as somebody who grew up in the time when we used to have static on TVs, I can tell you that tuning it in and finding that picture is a whole, like, I can see that in my head. But I also wonder, I don't know if this is too technical a question or not, but was this technique arrived at through mathematics or through observation of how the human cortex perceives and visualizes things?
I think it's coming from thermodynamics. So it's coming from something called the Langevin dynamics. Okay, but the idea is that these models are called the generative models because what you are modeling is a distribution. It's called the probability distribution. How to explain it in a simple way? Imagine that there is this space of all the possible images. You teach the model how to reverse the noise of all of these images. You have a billion images, you add noise to them, and then you ask the model to learn how to reverse this noise. But you do it in a conditional way, meaning that you also tell the model, okay, remove the noise from this picture, and I'm telling you it's a dog. So I give you the text. And then remove the noise from this image, and I'm telling you it's a cat. Then the model learns to associate the noisified version of a cat with the label cat and the noisified version of a dog with the label dog. Why it's called generative? Because you start from pure noise and you can generate something novel by giving it the condition. And the condition is what you want, the text. So if you tell it cat, the model will try to remove noise thinking it's a cat. But the noise that you give it, it's pure noise. So it's different every time. So the model is thinking it's a cat. So I maybe I should, draw a little lines here, little lines there. Maybe I should make some mouth or some legs, etc. But it will always be different because the starting noise, the starting point is different. So all generative models actually are like this. They always start from kind of some input that is different every time, and they always generate something new.
It's creating order out of chaos, essentially.
Exactly.
Okay. This is so cool. Let's move to, in writer's world, we're focusing mostly on text generation at this point. I don't know if it's in our roadmap to do image generation, but right now, and we do image analysis.
Yeah.
But are these two concepts of image generation and text generation related? And what's in common and what's different between these two?
They are both generative AI, meaning that you are generating something given some condition. In the case of text, you are giving the prompt as condition. In the case of image generation, you are giving the description of the image that you want. So they are both generative AI in this sense. They are also generative AI in the sense that they are both probabilistic models, means that they learn some probability distribution. In the case of text generation, we learn what is the most likely next word after the prompt. Actually, technically, it's the next token, but we can consider it as the next word. And right now we have like image analysis, which is more similar to text generation than it is to image generation. So with image analysis, for example, you are telling the model, okay, here I'm giving you an image and use it as condition to generate some text. So the image becomes the condition because it's part of kind of the prompt. That's why you ask the model to analyze the image. So the model will leverage all the condition, which is text plus the image, to generate text. What the language model is learning is always the same. So predict what is the next most likely token given the condition, and what changes actually is the condition. So the condition is image and text instead of just text.
The sophistication of these models has just exploded.
Yeah.
And I'd like to hear about your impressions when you first started working in this field. versus where it is today and where you see it going?
Okay, when I started, actually, I was so fascinated about diffusion models. It was such an amazing concept that there was actually that time there was also what is known as GAN, the generative adversarial network. Now they are not so popular anymore, but the concept is the same. You start from pure noise and you generate some data. I believe that there has been a scaling effect right now. So we have bigger and bigger and bigger models because we have seen that bigger models produce better results. I believe right now we are arrived to a point in which you want also to improve not just the quantity of data that you feed to the model, but you improve the quality of the data. So, because just keep growing, the size of the model makes them super expensive to run. So, we are now working on the optimization, I think, phase of machine learning. Because at the beginning, when we trained these kind of models like stable diffusion or language models, we just fed a lot of data. Like you just scrape the internet, okay, scrape 1 billion images, okay, it's not enough, scrape 2 billion, scrape 3 billion. Right now, I think it's not giving the same increase in performance that it used to. So now we are trying to, okay, not just scrape, but then filter out the best ones and filter out, the good, maybe improve the quality of the data that is available instead of just. And I believe that synthetic data will play a big role also in the future. So like data that has been generated by other machine learning models to improve future machine learning models.
So as you talk about this shift from this expansive, just let's make these models as big as possible to let's specialize these models, I feel like that also follows the trajectory of how we evolve as experts and learners, right? In primary school, it's about just info dumping from everything. We learn as much as we can. And then we finally get into university and, or hopefully, if you figure
Yeah.
out what lights you up, you do. And you figure that out and then you hone your craft or your area of expertise.
Yes.
But also I feel like I'm verging on anthropomorphization. Yeah. Do you find yourself wrestling with that ever? Of you work with these machines, but you might find some parallels between how these machines learn and how humans learn, and where's the line there?
I believe that it's an exploratory phase for me right now. At the beginning, I was interested in everything. Like I just wanted, learn this and learn that and learn this and learn that. After a while, you find kind of your focus point and you concentrate mostly on that. However, machine learning is one of those fields in which you are never bored because there is always something new every day. So right now, for example, I'm personally attracted a lot to optimization of these machine learning models, especially on the hardware level. So like how can we better leverage the GPU, for example, to make this machine learning more efficient or faster at training or using these models. And it was a field that I didn't explore before. And it's just happened as a natural transition. Like you specialize in these models, you understand how they work, then you try to understand, okay, but let's try to understand the hardware that runs them. Then after a while, maybe you start exploring how can I optimize these two things. There will never be a point in which I will say, okay, I know everything and I'm at that end, because there is always something more in this world that you can explore. So I believe that as long as you put time into something, you will always find your way. There are multiple paths, right? You start exploring a little bit of them. Eventually you realize which one is worth exploring. And then you just start working on it. And then you start going deeper and deeper and deeper. And thankfully, this is an infinite road. Like there is no end. So I will always have something to learn.
My question also was asking ultimately something that happens out there in the world when interacting with AI, which is that encounter, that uncanny valley encounter of that moment of wait, is this just a machine, right? Is this gaining some sense of consciousness? Is it gaining sentience? In your work, do you ever experience those moments? And if so, tell me about a situation. If not, tell me why not, right?
I do think actually about the implications of using AI models at scale and the societal impacts of machine learning models. To be honest, I believe that a lot of the news that we see around, like doomsday, it's a little bit too much. We are not up to the point in which we have models that can reason automatically and can, leverage the information and improve themselves automatically. Eventually, when you train models and you work with data, you always keep in your mind this machine learning model is just trying to replicate the patterns that it's seeing. So if you feed these patterns, it will just replicate these patterns. It will, of course, find something novel, because that's the whole point of generating data. You want to generate something new, right? But I believe that it's all up to us how far we want to go. So I don't think that right now we do have the tools or the resources to arrive to a point in which we say, okay, we went too far, or we are going too far. I don't think we will have that in the immediate future. I do, however, think about the societal impact of using machine learning models. So there are good usages of AI and there are bad usages of AI, just like any technology, I would say. Someone said AI is like the electricity of the current era. So like we are discovering something new, something novel, something that has never been seen, and it will change our life a lot. But just like electricity, it can also, it can be used in many ways, and AI can also be used in many different ways. But for sure, it's going to impact every aspect of our life.
As a user of AI, there's all this stuff happening under the hood, and the outcome is very human-like. As a user, and many people who are users, their imaginations get sparked, and they can't help but apply a sense of humanity to
Yes.
this technology, whereas you are under the hood. You are deep in the wires of this. And so you're confronted with the reality of its machine like nature on a day to day basis.
Exactly.
So you don't get caught up in that type of fancy, essentially.
Yes, I believe I'm more connected to the data, so I always see the mechanical part of what we are doing.
When we started talking, you talked about these multimodal models,
Hmm.
and you're very excited about that. Where do you see them going? And you said this is very much related to how our sensory systems work. Talk to me a little bit more about that.
So first of all, I believe that the biggest use case of AI for many people right now is interaction, right? So text-like interaction. A lot of people are using, chat-like applications for day-to-day work, or just exploratory phases or generating content. If you could do that at any moment of the day, in any place, in any scenario, it could affect your life in a positive way for many reasons. Right now, for example, we need to look for some information. We always have to, take out your phone, look for the information, try to filter out the good one and the bad one. You wake up in the morning, filter out the good news, the bad news, get a summary, try to, yeah. If you could have someone who could help you organize your day, always knew what's your next appointment, how to get there, based on, or on your routine, it could summarize what is the, I don't know, today's schedule, what you should focus on, etc. I think this is the next level kind of work assistant that you can get with multimodal. So you combine all these modalities, so you can connect with the human better. So you can be faster, you can be more engaged in the day to life operation. Right now it's an active process to open your browser and to interact with the machine learning model. If you have multimodality, it becomes a passive. You have it always there, and you can leverage it whenever you want. Of course, it all depends on who is using it and how it's using it. So it would make my life much easier, I would say, for me personally.
I can tell you that as somebody who has to outsource my executive functioning anyway, because I have ADHD, that this would be again another. I talk a lot in this program about how AI is a key to accessibility a lot for people with neurodivergence, and I can imagine how having a proactive executive function out there in the world helping me do all of these tasks that just take a lot of mental energy to achieve and take away from my day-to-day enjoyment of life, it would literally be life-changing. And if it's again one of those things where here I am in my space, but I can imagine it would be a ripple effect for anyone.
Yeah.
So, what a cool future we're looking at.
I mean, the multimodality adds, you can integrate it in a lot more use cases. Like it could be, can help you not only at your work, not only being more productive, but also help you in your day-to-day operations, like personal life. So imagine you want to focus more on eating habits or fitness, and you have this friend who can help you and watch you how you do your exercise. Or your shoulders are too high, too low, or did you forget to take the stairs today? Why are you taking the elevator or something like that? Yeah, I think that would help a lot of people. It's like having someone by your side. But of course, it all depends on what are the use cases, I would say.
Yeah.
I mean, I always think about the societal impacts of everything. So I believe that just like everything, you have to always consider, the societal impact.
Yeah, it's interesting when we talk about this new technology. The first thought is often what's in it for me?
Yeah,
And then what's in it for the world?
exactly.
And who, the bad actors or the people who have more power to gain from wielding it against others is definitely something that should be top of mind. And it's validating to hear that it's something that's in your mind as somebody who's working in AI.
Yeah, but for example, for education, it would be a game changer. Like imagine studying by having an assistant who can hear you, who can see what you're seeing on the textbook, and can help you understand the formula that you can't understand by yourself. So before, maybe if you have a private teacher teaching you, then you can understand it better. Or if you have educated parents, you can understand it. And if you are coming from a poor family, then you are more limited. But this way, you are actually giving it accessible to everyone, all the same knowledge to everyone. I think that's a game changer for society.
And you're tailoring it to everyone too.
Yeah,
It can be
yeah,
so
yeah,
individualized. Whereas right now, especially in education, things are so cookie cutter. It's very hard to make accommodations for kids who have personal challenges and health challenges.
exactly.
So yeah, I imagine that it could be a great equalizer in many ways. Something occurred to me as you were talking to me about these multimodal models and also the text generation models. You are very multilingual. How many languages do you speak?
Okay, so my parents are from Pakistan, but we live in Italy since many generations. So my mother tongue actually is Italian, but my parents taught me Urdu, which is the Pakistani national language. When I lived in China, I started learning Chinese, and I lived there for 4 years, and I studied Mandarin by myself, mostly actually because I wanted to, interact with my colleagues. I was working with the Chinese colleagues all the time, so I couldn't use much English, especially when you're dealing with customers. They really appreciate if you can speak the local language. And English, of course. And right now I'm learning a little bit of Deutsch, so German.
Just doing that on the side along with your YouTube channel. No fair. Uh, do you feel like this approach to language, a love of learning language, has impacted how you interact with AI and machine learning?
I would say that learning Mandarin was a game changer for me. So, China is a country of 1.4 billion people. Historically, they have been kind of isolated from the rest of the world, so they have not been like colonized like the rest of the world. They have never engaged in big wars, etc. So they have been kind of closed to the world until the last century. So when you speak Mandarin, you are opening a whole new perspective in your life. You interact with people and you interact with their history, and you interact with a lot of machine learning content that is coming out of China, which I could not appreciate if I couldn't speak Mandarin. So I am engaged actually a lot in the Chinese AI community. I do interact a lot with the Chinese researchers, and they have their own, technologies. They have their own like research areas, and it's kind of fascinating also. So actually, yes, it didn't impact machine learning by itself, but it impacted my ability to communicate with people, and which impacted my kind of machine learning experience, because I get to know about this machine learning world that is happening in China, which is slightly different than the rest of the world, because China has kind of its own internet, so they have their own content. Yeah.
And I have to imagine Chinese or Mandarin is very like etymologically different from
Yes.
European based and Arabic languages and
Yes, yes,
South
yes,
Asian
yes, yes.
languages. So there has to be so many different techniques of different dimensions of machine learning that we as English speakers, as people with Indo-European languages, would never have thought of before. I-
Yeah.
Is that on target, or is
Yes,
that
yes, yes.
not something? Okay.
No, no, totally true. Chinese is totally different in many aspects, but one thing, I mean, why I started learning Mandarin, not only for practical purpose, mostly because it's complicated, so I'm fascinated by it. You know, it's the more it complicated, the more it engages me. And the another thing that fascinates me a lot about Chinese is that when you study Chinese and when you study the characters, you are not only studying a language, you're studying the history of a country,
Yes.
because that character was drawn thousands of years before, hundreds of years before, and it was different, and the change to that character reflect the history that the country has gone through. So it's really fascinating also from this point of view.
Language nerd
Yeah.
right here. If there's a through line to the story that you're telling of your life, what is that through line?
I'm a strong believer that if you want something, you can get it. Like you just need to do the extra step that most people are afraid of doing. Like for me, even meeting my wife was a life changer for me. It was very difficult for me because I come from a conservative Pakistani family. So from my parents wanted a Pakistani wife for me. And also my wife, she coming from a small town in China, and her parents wanted a Chinese husband for her. So making these cultures kind of interact with each other, accept each other was very difficult for us. But if you want something, you can make it work. And the same happened to me when I was a kid. My family had financial troubles. So I started working very young. So I actually did my high school while working. Like I used to go to school like from 8 to 2 o'clock, and then from 2 o'clock to 6 I was working, and I was the only income in my family. It was a very difficult time, but if you as a family want to change things, you can, and we did change. If we want to, I want to be with my wife, I can. It's challenging, but I can. If I want to get into machine learning, it's hard, but I can. You just need to put the extra step that most people are afraid. And sometimes you should take that leap of faith, even if it's scary. Just prove to yourself it's really what you want. So that's the key. Like, you want to do it, just do it.
And might I add, Umar, you've mentioned several times that you're somebody who likes to go after complicated, challenging things
Yeah.
too.
Yeah.
So maybe it's hard and go after it because it's hard.
Yeah. Yeah. Yes, yes, yes. I think that's what I like about life is a journey in which I mean, I am trying to find myself, and I find myself by doing different things. I am trying to find my own dimension by doing, going to different places. Why I went to China? It is to work there because I wanted to explore a completely different environment, to see the world in a different way. Because I already traveled in Europe, I already saw Europe, I already saw Pakistan, I already saw a kind of Asia, South Asia. I already traveled to the USA before going to China. So I wanted to say something totally different.
I've loved talking with you. Is there anything we haven't talked about that you wanted to discuss before we say goodbye?
Oh, there are so many things, but I would say that language learning is something that is always worth it. Like, don't concentrate on languages that are good for your career. Don't concentrate on languages that are, you think they are cool. Just learn a new language because it's going to open a whole new world to you. Like, you will be able to read more literature from that country. You will be able to relate to a totally different point of view from the one that you are born with, which will change your life in an intangible way. You will not realize how it's going to change your life.
And coding is also
And
a
coding, yes, yes, yes,
language as well.
yes,
And that opened up your world to where you are
yeah.
now. So amazing. Thank you so much for talking with me today.
Thank you for having me.